So in section 2.3, we learn how to use the shell method to find volumes of revolution. And in this problem, we want to find a volume for this function y equals x minus 5 to the 1/3 power minus 2 on the interval 13 to 69. You can solve this problem using the disk method, but sometimes the disk method might not be available. Sometimes the integral you set up is hard to integrate, or sometimes you see a questions just ask you to show me the setup with using the shell method. Then in that case, you must use the shell method. So the shell method, before we do so, we must take a look at the graph to understand what we are dealing with. So this is the x-axis, y-axis. And when you plug in x equals 13, y will equal 0. So 13, y equals 0 right here. And when you plug in x equals 69, y equals 2. So this is the graph for y. So you need to understand each point here have an x coordinate. So this is the x value and a y coordinate. This is the y value. So those are the points on the graph. And the question is saying, I want this piece and I want to rotate it about the x-axis. So you will get like a kind of like a head shape solid. So now we need to look for, okay, what is the height or radius of the shell and what is the height of the shell, because this will be how each shell looks like, okay? So it looks like that. So we call for our formula. The volume equals integral, because it's about the x-axis. We call for C to D 2 pi R H dy, okay? So in our case, it'll be easy to see what is the R. So R, so volume equals integral with respect to y. So what is the y limit? So you go through y from 0 to 2, right? So integral from 0 to 2, okay? You can factor out the 2 pi already. What is the r in this case? The radius? The radius is y. Now what is the height? Okay, the formula in the textbook is g of y, but what is it? We have to represent the height using y, right? So the height is right here. Do we have a formula for this line? Not really, but what do we have? We have a formula for this line from the y-axis to the point x. That is length x. But if you're moving this line up and down, okay, this entire line up and down, they all add up to 69, okay? So the blue piece plus the green piece will add up to 69. So our height is actually 69 subtract x. But we can't just plug in x in here. We have to solve for x in terms of y. So if you go back to the original function, we just solve for x, okay? So y, you add 2 on both sides. You take the third power, and you add 5 on both sides, you get x. So that's the expression for x. And your h is 69. Subtract your x is y plus 2 to the third power plus 5. Now you complete the setup for this volume. And to solve this problem, you just need to recognize it's a polynomial. So you just simplify everything. So you get the volume will equals 2 pi integral from 0 to 2. So you expand this polynomial and simplify. You get 56y minus 12y square minus 6y cubed minus y to the fourth power dy. And then you just apply the power rule to find the antiderivative. So 56 over 2 y squared minus 4 y cubed minus 3 over 2 y to the fourth power minus 1/5 y to the fifth power. And then you evaluate 2, plug 2 in, and then you subtract the value when you plug in y equals 0. Then eventually you should get 496 pi over 5.